Okay, for those of you who don't know me, I think many of you do know me. I'm Ed Campbell I'm with Commercial Chem Tech. It's an industrial water treatment company. We deal with the specifics of water treatment in every single building you could imagine. And the main goals that we're looking at after for our clients is less water, less energy. And those are two powerful equations that are affecting every building. And so if we can enter the building, look at the systems, get them to use less water, less energy, that's one of our goals. And so in this process, through your expansion here, we've come up with a design, with your help too, and ours, to come up with a way to manage the water in the boiler systems that you've got here, and on a general way. So basically, Pete's got it here, you have flow meters, you have controllers on the boilers that are associated to surface blowdown, and those are intuitions. We didn't supply those, and I'm not sure if your other vendor has given you a class on it, but what that's heading toward is working with your building management systems. You get more information on the surface blows. We'd be able to augment those in the future, right, as connected to the flow meters that you've got. And so where we're going with this, as the boilers flow water in, we're managing that on a flow meter. It's sending it to a controller. The controller is going to sense how much water is going into the boiler, and then we're going to pump in three associated chemicals to this system. One of them is a boiler compound, one of them is an oxygen scavenger, and the other is a steam line agent. And so as the boilers are making up water, the controller will calculate how much of each chemical can go in. So a little bit, our goal is to kind of approach a system where it's a little bit out of sight, out of mind. Once it gets locked down, it's going to be able to feed the chemicals at the appropriate rate to reach chemistry levels that we'll talk about this in a bit. But we're going to try and target these chemical levels. It'll be less work for you guys. It'll be automated. Again, we're in a process where we're locking that down because flow rates to these boilers are we have just a few weeks of information, I think, on it. But once we start to get the flow rates, we'll know exactly how much of our chemical will be going in on this pulse control. Now, you don't need the flow meter for this whole system to work. Your old system's been on pulse control. So much is just kicked in. But the disadvantage of pulse control is it doesn't modulate the feed around it, right? Oh, come on in, sorry. Yeah, it doesn't modulate the feed around the boiler. So what we're going to try and do is, with this system, we're able to modulate the feeds associated to the demand of each boiler that you've got. On the back of my card here, if you can look at it right there, those of you who have a card, not Katie's, but this back of this card. The two major problems in boiler water treatment are scale on the boilers. And if you look at the back of my card, the boilers can get scaled up. And this is an associated, you're going to have the cost of fuel changes constantly. So that would be, but it really shows you the relationship between keeping the boilers clean and scale free, which is a problem in boilers. And the other major problem is sulfite control. We add sulfites to the water to capture available oxygen in the water. Oxygen can pit the boilers. And so those are the main two targets that most of our boilers we hear that fail, not ours, but are because the boilers got pitted or scale developed on them and they need an acid wash of them. Okay. We've mitigated some of that here because you have softeners online that are taking the calcium out of the water. Those are in an upgrade coming to them. So we're able to take a lot of the calcium. Softeners cannot remove silica from the water chemistry, and silica can scale a boiler. Phosphoric acid washes are common to wash those out. Okay, so if you look through here, we're managing this with a set of pumps. You have your own, we have our old flow meter that we supply here, past that. We're going to manage this through, if you look here, This is the pulse controller, symmetrics, that are online there. So what these two, there's two sides of this dual pulse symmetrics. Water's going to come in, it's going to accumulate, and it's going to pump boiler compound on one side, or corrosion inhibitor, and oxygen scavenger, and neutralizing amine on the other. So that's the main tube flow. It's going to calculate, and what we're going to do is adjust these. So as flow comes in, we're going to adjust the feed rates, or the time. It's going to accumulate how much time, how much feed is going to come on for a specific period. It can be 5 minutes or whatever, depending on what you're doing. We're going to then associate that to the pumps. Is the pump the next one? Yeah. So it's going to feed rate. We're feeding the accumulations to this style of pump. And so we can. There's a couple ways to manage this. We can manage it through the pulse rate on the pumps, or we can manage it through accumulation of the water. So you can actually really, in locations where we have this, really start to fine tune the water chemistry for it. Again, it's a little new here, but we're heading toward that type of situation where we can super fine tune this. Injection quills, that's separate because we're injecting directly into the boiler, and I covered the symmetric controller. Okay, I want to talk a little bit about troubleshooting the system. On these boiler, what you'll see on the symmetrics controller occasionally is what's known as an OUF reading. Where is that symmetrics controller? It's going to print out, this is an error code on the controller. What that means is, I haven't finished pumping the exact thing you put in last time and you want me to pump again. So as we lock this down, you might have what's known as an OUF reading. Just turn the controller on and off. It might be just a sequencing error, but
sorry, the tile people are here with the ceiling tiles that they called Mark, that he's not here. Do we know where we want them? They're just going to be at the loading dock.
so as we get going here, that's one of the common errors you'll start to see. As we lock these down, you might get what's known as an OUF reading on them. We can offset the accumulations a little bit so they're not sequencing at the same time, and we can increase the pumps for the moments that one or two are on. So we'll have to manage that early on in the equation with you guys. But that's the most common troubleshooting error I think you're going to engage here. And it's going to show up on that part right there where see the accumulation here, there's 0. That'll read OUF. Again, it's covered in the manual here, but that's essentially what it's saying. The other side, you're kind of looking at ups and downs of what we've supplied you, but one of the downsides that we find people, they forget about this, but if you drain the boiler, it's easier to shot feed chemical into the boiler when you refill it. Otherwise, what's going to happen is if you strictly go through the controller and add enough, you'll get an OUF reading and nothing will get injected. It'll start to err. And so if you drain a boiler for a test or you drain a boiler for its inspection, you're going to want to make sure you put one or two 5-gallon buckets into the volume of these boilers, particularly maybe 10 gallons into the larger ones, 5 gallons into the smaller ones. But that'll start to modulate again out. That makes sense. So the downside of this is if you forget to do that, we're back to trying to lock it all back down again. So always when you do go through an inspection or drain a boiler, make sure you add 5 gallons in 3 or 4, 10 gallons in 1 and 2. And that'll start to lock the controller down. Other troubleshooting things. I like to think the system's pretty much error-free. We have a lot of places that use this, and it's very successful in locking down and modulating the feeds. And I have the SDS sheets here on the back. There's three types of chemicals that are being used in this. One's a boiler compound, one's an oxygen scavenger, and the other's a steam line. As the boiler creates steam, carbonic acid starts to develop in this boiler. That goes through the steam line. So there's two types of chemicals. The oxygen scavenger and the boiler compound are water soluble. The steam line chemical is not water soluble. We don't want it to be, because we want it to carry in the steam and neutralize the acidic nature of that steam to protect your steam lines from corrosion. Okay? So that's the goal of that one. Again, we can modulate it separately with the feeds, but again, in those cases, we're using degassing pumps, because if you don't use a degassing pump and you put it in the heads of these pumps, they would just degrade them very quickly. And so you need a degassing pump. Some of the other chemicals are, you can interrelate them, but for the most part, that's why you see degassing pumps. So the steam goes to your autoclaves, which you're measuring, right? And Pete and I started the program here where they're measuring actually the quality of the steam in the autoclaves to prevent the corrosion. Depending on, there's three types of steam line chemicals: morpholine for short line, DEA for long line, and cyclohexamine, DEA for midline and cyclohexamine for long line. So when I first got here, they were using pretty much DEA and maybe a little morpholine, so they weren't protecting the lines all the way to the end. So one of the changes we incorporated when we came here is to put cyclohexamine mixed with morpholine. So those are the chemicals that are in your, and again, they'll have a vapor with them, right, as you use them. So you may want to have some personal protection when you're involved with those. You measure it at the end, and you can through your sample coolers. Most of the water that's used in a boiler of advantage here is going to be through your blowdowns, right? The way the water is going to leave, and it's evaporating. What we're also heading toward is, because you have flow meters online here, everybody has a house and if you look at your water bill at your house, there's two sides of the water bill. There's sewage and your raw water. Everybody's got that, right? What we've also been able to incorporate, many of our clients, is a long-term program where they put the flow meters, because most of the water that's used in a boiler is just boiled off, right? It's not going to sewer. So by having flow meters online, you can go back to the water department and say, hey, look, we deserve a sewer deduction here. And many of them are in favor, and it's actually quite a bit of money. We take care of an animal research facility that has like 8 steam boilers constantly boiling water off.
Because the city just measures your water usage, and then they attribute your sewer based on that.
Yeah. And you should be familiar here with it, because you get sewer deduction many times on your on the water supplied to the plants and everything around here. So the cities are used to sewer deduction, but you have to confront them. We're heading toward a program where we're going to confront them over sewer deduction on these boilers. They're going to say, well, how do you know what's going in them? That's where you're going to show up and say, here's the water that's being blown. We're only blowing them down 10 seconds a day. There is a surface blow that would be involved here a little bit, but you can put, for the city's interest, 99% of this water is being boiled off, right? So that's going to be an enormous saving. It's going to offset all of our chemical costs quite a bit. So just as a word down the line. So another kind of a bit of an advantage. Okay, involved in our treatment program, we come by once a week, and you'll see these reports online, and there's right here. What we're trying to do, these are target areas that we're trying to treat these boilers within. We'll have a written report on site. It goes back, put into a digital format, and the main things we're looking at are pH within a certain range, TDS, how thick is you guys properly blowing down the boiler. We can tell by this, or if the surface needs to be adjusted. Alkalinities, this is part of an equation. They're not really that important, because we're mostly looking at hydrate alkalinity This tells us the amount, percentage or the amount of our chemical that's in each boiler. Do we have enough? We're trying to hit a range here between 120 and 190, 200's in the range. We're trying to hit that range. So again, this is all part of a formula. You don't really need to know it much. We can get into it. But we're focusing on hydrate alkalinity. The next is orthophosphates. There's orthophosphates in our main boiler compound. What that's doing is bonding up with calcium. We're using a thing called precipitating water chemistry. In this, the chemicals get into the boiler, they could get all the impurities together, and they precipitate it to the bottom for a bottom blowdown. So they're gearing up for these bottom blowdowns, okay? If you just rely too much, we're at a building that, oh, I'm blowing it down through the surface every day. They never went through the process of blowing the boiler down out of the base of it, and they plugged it up essentially, right? So again, precipitating water chemistry. So we're monitoring orthophosphates, we're monitoring sulfites. How much raw oxygen is in this water? We don't want these boilers pitted. There's a separate, we're putting OX21, which is an oxygen scavenger. We're managing that. Too little is mostly what we're looking at. Too much is just sort of a waste of money. We want to manage that. We don't want you just pumping this stuff in. It doesn't really help the boiler much, but to have too much in it, I mean, but you don't need that much in it. You want, if you can keep it a plus 30, under 100, you've really prevented any pitting of the boiler. You've captured a lot of raw oxygen. The reason that that's important is the O part of H2O is very corrosive. It's going to find something to go do. So what we're essentially doing is giving it something to attach to. And if it attaches to it, it's not going to attack the boiler, interior part of the boiler, okay? So that's a little bit of the goal. We get more into that in a water treatment class you might want. But again, we're shooting for these ranges with this control system. We're here every week to take a look at that. Pete's around, of course. Many of you know him. So at the end of our report, what are the changes to the system? Are there chemicals on hand? Is the softener working? We're able to determine that. Are we adjusting the pump feeds? And are we adjusting the blowdowns? Those are the main things we're going to want to take a look at and make adjustments to as we lock this down. Again, that's where we're going with it. What else is here? Other things you need, boiler blowdown logs, they're essential. We want to know what you're doing to these boilers. Particularly, I forgot to have, or the weekend crew didn't show up and do it, anything like that. We don't want, poor information in will only create bad outcomes. So the better that the two sides communicate. Many places we have a dry erase board that we write. We go around to each boiler and have a dry erase board. These are the adjustments to the feed we've made. These are the adjustments to the blowdown. So again, when we show up at this boiler, we can take a look. So if I get knocked off, someone else comes and takes a look. What was this guy doing here? Okay, so that helps keep management of it. Chemical levels in the barrel. We've switched to clear drums here for a clear indication of when you're getting low. They'll show up. It's hard to get clear plastic drums lately. I don't know if you've figured this out on other stuff, but it's just difficult to get them. So we're having to deliver these chemicals in solid colored drums, blue and black, pretty much, but transfer those into the clear drums. And that's another way you can look at it. Say, hey, I'm getting low, I need this, right? The other thing that we're heading toward with PeaceHealth, and you've already have what's known as a water management plan here, but we're going to have to augment that plan with your new system here. But it's a way we come on site and analyze all the water that's being used in a cooling tower and this, and what is the management controls for all these systems. Again, every hospital needs one right now. They're heading toward every major building in Seattle's getting them. Schools have got them coming. But there's kind of this big scope of a water management plan for every building. And I think a lot of what we're supplying here will help be good information for the water management plan. Rest pretty common. Posting LACE inspection card conspicuously. Posting on-site personnel holding the boiler operator's card. So it's just pretty easy here, but some places we go like, who's in charge of this? You know, Pete and I were at a hospital last week. No water in the sight glass of the boiler. It's just firing off. I'm going, who in their right mind wouldn't turn this thing off like I go? There's that red button, right? Just, yeah, you gotta, you know, as a life, all these management shut up because as a life-saving procedure, we should get out of this boiler room, turn the thing off. Anyway, it's gonna take both sides to do this and do it right. There's just no way around it. You can watch us, we can watch you, but a lot of these tests that we're doing will be a clear indication from our end. Are you blowing the boiler down right? Is the softener working? And we looked at that. What might be going on in sulfite? So again, this helps us see what your end's doing, and then you can also see what our end's doing. We're heading toward, Chemtech didn't come up with these ranges. The National Association of Corrosion Engineers sets these. And so we're just following their guidelines. We want to make sure these boilers are operating clean and safely and pass their inspections every year. So, and honestly, if you do all this, they will. So, okay, that's kind of quick and speedy and dirty. Okay, questions?
I have a question.
Okay.
When we're doing our blowdown, are we just dumping condensate that isn't getting into the system? Like, what are we doing when we blow the boiler down?
We're using precipitating water chemistry. So all these little bits of particles and crap that get in the water, we're collecting. Water looks pretty pure to you, but it's got nickel, selenium, you know, it's got silica. There's all kinds of things in water. I think we have a pure water report here, don't we? For the site that has everything in the water. So it collects
So
all those
it's
per
an
chem.
accumulation.
Yeah, collects them all, and it's lowering to the bottom of the boiler, and that's what you're goosing out. And if you don't do it, it starts to eventually communicate.
That's it.
Thank you. So just to sort of help elucidate that question, the minerals that are in solution in the boiler, they're happily in solution. When the water evaporates and becomes steam, what it leaves behind is concentrated, right? Now, left unchecked, that could just, it would start to play down whatever hot surfaces and cause the scale. So the chemicals that we introduce, particularly when we have enough hydrate alkalinity present, that in combination with the phosphate causes the calcium to precipitate out. So it's like, hey, you know what? I'm not going to go play it out on a hot surface. I'm just going to glom onto the acrylamides that are in there and form a harmless sludge in the bottom. So those are the reactants. So typically the conductivity sensor periodically senses the TDS and the chlorides that are in the top part where the highest density of concentrated chlorides are. The other stuff, it reacts out and it's managed periodically by a bottom blow. Those are the reactants. So when you get these out, the chemicals can actually do their work. If these accumulate in there, the chemicals will start working on them. It's like, no, get those out of there. Those are the reactants. So that's sort of the idea, the way we see it.
Yeah.
We also, as a unique part of Chemtech, we use a product in our boiler compound called lignosulfonate. That's the lignin pitch from trees. It's an all-natural product and everything, but it's kind of a gooey substance, and it gets in there a little bit and helps drop everything to the bottom. So, again, we don't, steal a little bit out of that proprietary knowledge, but.
If they don't bottom blow, this stuff just packs up and just, it's really pretty ugly.
And you could warp the tubes in the boiler, overheat them and warp them, and then start to separate there. Yeah.
So right now you have the connectivity sensors and the digital displays came from Coal Industrial. They tuned those a little bit. So periodically they sense what the conductivity level is as a sample, and then when it reaches a certain parameter, they blow down to drain. And so that keeps the conductivity within the boiler within a certain range. But still, it's incumbent upon the operators with the advice of the consultants, to periodically blow the reactants out. So some people, they don't really get this, but these are really two different ways to help fine tune the chemistry within the boiler proper. Not only are we fine tuning it with our injection pump, with our controller for chemical additives, but now on the backside of it, we're fine tuning it with our automated blowdown and our manual bottom blow. So you have two different ways of looking what's coming in and then what's going out. And we can really tune those. So over time, the trend, it gets really smooth. Chemical usage is down, energy usage is down. Spectra opens it up and goes, hey, I like that.
The other thing, when that surface blow goes off, that's where it's the most acidic part of the water, right? So we're also able to blow off that acidic layer just slightly, get it to drop, and it really improves all the chemistry in the boiler. So it's not reacting out there.
So right here, where you can imagine during very vigorous boiling, when there's a lot of demand and the flame is really intense, there's a mat that forms under here, which has surface tension in it, and the bubbles, they come up and they jump through and they carry out a steam. So what's left behind is pretty thick. And that's what this little quill that drops down quite a few inches below the water level. And its mission is to manage that, which is in the top few inches of the water column.
All right.
Okay. Your guys' meters or the pulser, you
Yep.
guys are just tuning the pump cycle or pulse cycle?
It's, two things are there. It's managing flow, so it's accumulating flow. Based upon this flow, which we set, a flow rate of, let's say, 5 gallons, it's how long is the pump going to go on? The next measurement is the measurement on the pump. How high are we going to put that pump while it's on for 5 minutes, right? So that's the tools, two sides.
The input connector, what is that seeing, your input?
Yeah, that's coming directly off your flow meter.
There's a pulse count that can be expressed here, like every 5 gallons. You can set this up here, the accumulator. This is channel 1, channel 2, right? Channel 1 takes care of both OX21 and B200. Channel 3 takes care of the steam line conditioner. So the controller has 2 channels. So for this channel, you might set it up to every 10 gallons of input, every 10 clicks, it'll initiate sequence for however long you want. Like, oh, let's just run every 10 gallons, let's run this channel for 5 seconds or 10 seconds.
And then that'll be matched to a pump feed that can go 300 pulses, I believe.
0 to 360.
0 to 360.
So you can
To
really
either
tune that in.
turn
Yeah,
that
just a little too much, back it down. Oh,
Yeah.
not enough, just back it up a little bit. So you have, maybe you could say this is sort of a coarse adjustment, and then this is the fine tune. Would be one way to look at it. I can set
We're
this up for
covering
every
this
5
controller.
seconds. When I sequence this, when I push this button, this lights up, and my display indicates the accumulation rate, and I can modulate that, dial that up or down. Then I sequence to the next one, and it's the timer. It's like I can dial that up or down, 5 seconds, 10 seconds. And then you go on to this channel, this will light up for channel 2. Same way, like, I think every 10 gallons I want it to initiate for sequence next one for just 3 seconds. Okay, so you can really fine tune each channel.
One of those channels gets plugged up, does it sense that there's a problem with it pulsing?
The OUF thingy is when there's an overlap, when there's a conflict. Ed could talk to you more about.
Yeah, basically what an OUF reading is, they want to feed separately. And so you don't want to end up in a situation where, look, you told me to pump for 10 minutes. I haven't finished pumping for 10 minutes. You want me to pump this one for 10 minutes. So again, there's an easy way around that. You turn the pump up higher for a shorter amount of time. So there's less overlap. But again, we're going to go through overlap periods here. We're going to get what's known as an OUF reading here, and it's going to show up in here.
Yeah, flow line gets plugged up.
Oh, you're talking about.
The Symmetrics really doesn't monitor what's happening at the pump.
You're
All it's
talking.
doing is taking the count of the flow meter. The flow meter pulses for how much flow goes across it. The Symmetrics counts those pulses and tells the pump to run. That's all it does.
Yeah.
It doesn't know what the pump's doing, and it really doesn't know what the flow meter's doing. It just knows that the flow meter says that it flowed.
And when we do these tests, we can identify, like let's say sulfites are low. We can go take a look at the sulfite OX21 pump and say, is the thing plugged? Is the barrel dry? Or,
You're talking about if there's a physical obstruction between the fluid of the pump and its way into the quill, into the loop.
Yeah, 'cause I noticed you get a little scale buildup. In the past, we've had them plugged up, different little tubes and stuff, and
Yeah, there can be little crystals that develop in there and foul up the works. Particularly sometimes in the suction of the OX21 crystals, but we have such a mixture now that it's like, it's not as likely to do that, but if it does, let us know. And in the meantime, you can just add some warm water in there and stir it around. Some of those crystals may go into solution, and then you can like pull on the suction tubing a little bit and get that freed up so it starts pulsing again.
I guess he's asking, when will you know that there's a problem? Might not know until your weekly visit
Oh.
and your measuring.
we're here once a week, and if this is low,
You'll-
then you'll have to backtrack through the OX feed system and see why is it low.
So the
Troubleshoot it.
So the other indicator outside of chemistry readings is, you know, you listen to the pump going, and you can tell by the sound, right, if it's
Oh,
like
good point.
pulling air or pushing liquid.
Yeah, it makes a very high click, click, click if it's just pumping air. It should be kind of quiet as a pump. And of course, other thing you can do is visually. If the chemicals aren't going down, something is up.
Yeah, I
So-
tried to get clear hoses installed so then we can see the fluid going through.
A lot of people put like the blue construction tape on the side of the tank in this market and then tear it off, put a new one on. And that way you can sort of get a clear indication that it's feeding. And that's fairly common actually in the marketplace.
We failed to mention that we also had chemical OX21 right to the DA tank proper. So the DA tank, its mission is to preheat the water that comes from ML1 and allow it to outgas, preheat it, put a little bit of pressure cap on there, and allow, there's a sparge tube in there, there's a whole discussion about the DA tank, but we add a little bit of OX21 there to sort of pre-treat it, to scavenge any oxygen. And then, of course, looking for residual in the boiler proper, we add OX21 to there. That's our fine tuning.
Yeah. You have to measure that a little bit because one of the things, there's less oxygen in hot water, correct? But as you add this new cold water, when you bring the boiler online, there's a lot of unbonded oxygen, and we're going to want to make sure we bond it up as quickly as possible. Our boiler compound has actually sulfite in it too, so it's a really, that's where I'm going to say, if it's cold and you're going to refill the boiler, make sure you put 5 gallons in the new ones and 10 gallons in the bigger ones to just kickstart it. All right.
So it doesn't dissolve the oxygen, it gives it something to attach to.
That's
not
right,
away from
exactly.
your piping.
Like,
Yeah.
you know how like batteries, they sulfate out,
Uh-huh.
like your lead acid, sulfate. So the oxygen, scavenger, OX21, it's a sulfite compound, and it combines with the oxygen and makes it sulfate, which is harmless. It just binds up with oxygen. Now you have sulfate, which is like, just in there, it doesn't really hurt anything.
That's good. Good enough here, though. And you guys mostly been kind of looking through. Art, you have any other comments here?
The quills we're gonna wanna look out for, make sure they're not smelling water.
Yep. Yeah, there's, we use stainless steel quills here, right?
Stainless steel quills.
Yeah. Okay.
One more thing, what did you mention was on the BAS? You said it was looking at something on the BAS or something was on the BAS? or
Yeah,
no?
I believe that these controllers are capable of producing an output that goes right into your field panel to your DAS.
So the Symmetrics are not,
These ones aren't?
no.
No, Symmetrics
But
don't.
we are working with, between the flow meters and the controllers that are on the new boilers. To
Yep.
get a totalization out to the DAS.
Oh, good.
Yeah, that's how it's being done.
But the symmetrics have no output.
No,
No,
Symmetrics
no.
don't do anything but take pulses and run the pump for
Relay,
designated amount of time.
or just,
That's it.
a relay system is all it is.
City water, is that what we're gonna put on BAS? Or how much water we're pumping in?
We've got a couple of flow meters out there that we need to get calibrated and make sure that they're operating properly. We won't start totalizing those flow rates.
Properly, yeah. Okay,
With the new boilers, we also have a couple of steam flow meters now,
yeah.
which should be showing up in the BAS.
Yeah, they're, I think Cole supplied this, right? So
Yeah,
they can give you a bit of a training on them. If not, we do supply these all over. It's just as a function of this current relationship with SCOCON, this is our scope. So we're going to let them operate in their scope, their lane. We're operating in our own lane here for the moment. But if you still have trouble, we know the top people in the area that can come in and give a class on it.
Appreciate
So.
that.
All right. Exciting?
Thank you.
Okay. We're going to run outside and do a little bit of a field test here. You can happily join us or not, you know,
Field test of?
of the boiler water. This is what we're going to look at. This is how we're doing it.
We'll probably set the controller now, right?
Pardon?
We'll set the second cementers up today,
Oh, okay.
because
We
that
can,
flow meter's working for it.
okay.